Okay, today we're going to learn about integration by parts, which is a technique that can be used to find the product, a technique that can be used to integrate the product of two functions. So let's look at the formula. It states that the integral of u dv is equal to uv minus the integral of v du, essentially stating that over here, the integral of uvd is equal to uv minus v du. It's very important to remember that. And these v and dv are just variables, as well as v and du. And you're going to want to assign these variables to certain values, the most important of which is u. And you have to know when to assign u to what variable. And this acronym over here, LIPIT, can be very useful when doing so. The order of which these letters occur in the acronym is essentially the higher priority you're going to give to the functions in the integral. So if you see a logarithmic function, that you should automatically assign that to u, such as natural log x. Inverse trig functions is next. That should have the second highest priority, such as arcsecant x, for example. Parametric functions such as x squared should go next. Then exponential functions such as 2x or such as 2 to the power of x or e to the power of x. And then trig functions should be your last resort, such as cosine of x. And you probably don't understand anything I'm saying, so I'll just give you an example and we'll walk through it. Let's say you have the integral of, let's say x sine x. Now, we're going to want to assign one of these dv and one of these u. Now, sine x is a trig function, so we are not going to assign that u. X is technically a parametric function, so we're going to allow x to be u, and dv is going to be equal to the rest of the function, or integral. So sine of x, d of x, you must include that. And so let's find du next, as it's an important part of this formula. And it's just the integral of u. So it's 1 dx. Pretty simple. Let's integrate du, dv, such that we end up with v. And it is clearly just negative cosine x plus c. And so this isn't really necessary yet, because the plus c will show up in the end, because we're just going to integrate v later. So the plus c isn't really necessary. And so now that we have u, du, dv, and v, we can finally plug them in. So let's plug in u times v, which is just negative x cosine of x, minus the integral of v du, which let's factor out the minus from the v, and so we end up with cosine of x dx. And I should have allotted more space, so we'll just carry this down to here. So we end up with negative x cosine of x. Now, what's the integral of cosine? It is just sine. So we end up with this, and we must add plus c at the end. So the integral of x sine x is equal to negative x times cosine of x plus sine of x plus c. Now, it can be a little difficult to remember that u dv is equal to uv minus v du, which is why sometimes we use the tabular method. And the tabular method is essentially a special way to integrate by parts. You can use it if the variable u will eventually equal 0 when it is derived enough times. Of course, that is meaningless to you because I haven't given you an example yet, so let's do that. I start off by making a grid and putting u in the leftmost column and dv in the rightmost column. Now let's say that for the sake of this example, after u is derived twice, it is equal to 0. So u double prime is equal to 0 just for the sake of this. So we're going to start off by deriving the leftmost column until u or any of its derivatives are equal to 0. So we're going to write u prime, and then we're going to write u double prime. Now keep in mind that I said earlier that u double prime is equal to 0. So we're going to stop here. And we always stop on the same row for both u and dv. Now what's different with the rightmost column as opposed to the leftmost column is you have to integrate this side. So we're going to integrate dv, which is v, and then we're going to integrate v, which is just the integral of v. And we stop here because u double prime is equal to 0. So at this point, we don't necessarily cross multiply. Think of it as like half cross multiplying. We take the product of these two, and we also take the product of these two. Now we don't take the product of u double prime and this because this is nothing. We don't integrate this far. Now keep in mind that these alternate in signs. So this is going to be a plus, this is going to be a minus, plus, and this will go on indefinitely. Well, it matter. It's determined by how many times you derive u. So now we can write this out. We state that the integral of u dv is equal to uv minus u prime times the integral of v. And of course, we have to add plus c at the end. All right, let's try to integrate this function by using the regular integration by parts method. So let's first write out this acronym, LIPIT. Oops, that's not how it's spelled. Okay, LIPIT. All right, so let's divide this into two functions first. You'll notice we have 2 of x, and we have cosine of 2x. Now, there are no logarithmic functions here. There are no inverse trig functions. There is a parametric function, 2x. So 2x is going to be our u, and cosine 2x dx is going to be our v. So let's state that first of all. U is equal to 2x. And that means that d of u is simply equal to 2. We know that d of v is equal to cosine of 2 of x of d of x. And therefore we know that v by integration is equal to 1/2 sine 2x. Okay, now that we know that, well, let's write out this formula, uv minus v to u, and we can fill in the variables. So 2 of x is u, so this is equal to 2x times v. All right, I forgot about the 1/2, so let's just simplify this ahead of time. So 2 of x times 1/2 sine 2x, and that is just equal to x sine of 2x minus the integral of v, which is 1/2 sine of 2x, times du, which is 2. So we're just going to simplify this already by turning 2 times 1/2. We're just going to equate that to 1. So we end up with the integral of sine of 2x. Keep in mind, we don't have to put the plus c yet, but let's just solve this. So x sine 2x plus, because the integral of sine is negative cosine. So we're just going to, a negative times a negative is a positive, so this turns to a plus sign, plus 1/2 cosine 2x And here we do have to put the plus c. All right, to integrate this function, let's just start off by writing the acronym. Keep doing that. Keep putting the acronym lipit. And let's also divide this into two functions. You can clearly see x squared and e to the x. X squared is a parametric function, which is before an exponential function, and e of x is an exponential function. So we end up with u as, or sorry, we end up with x squared as u. And you'll notice that u is, you can eventually differentiate this such that u triple prime or double prime, whatever, is equal to 0. And we could do that with the last question as well. However, I just wanted to cover both topics. So let's set up the grid. I don't really know how many differentiations this will take, so let's just add a few rows. All right, let's put u in the leftmost column and e of x in the rightmost. Let's differentiate this a few times. So you end up with 2x, 2, and whenever you derive a constant, it is equal to 0. And now we have to integrate this side because this is the dv side. The integral of e to the x is e to the x, and yeah, we can just write this a few times. And remember that these alternated signs, we have to establish that. And from here, we can just multiply these. It's a bit messy. But we finally have our answer. So 2x times e to the x minus 2x times e to the x plus 2 e to the x plus c is what this integral is equal to.